Hi, beer. Yeah, I was eating soup, so it was slow and I had the mic off. Why? I set the schedule logging to step and I print something and as some threads start running. Why? Okay, let's see. Hello, Mr. I don't know what it is. Russian name. Yeah, when the war started, or something close by ish, I thought let's buy 250 cans of soup, and I did. And then it turns out you can only keep them 2 years. So I have to eat at least 1 can of soup per day, or per 1, 2 years, maybe a bottle less. I don't know. Anyway, I'm eating a lot of soup now, which is cheap. They were priced off too. All before the prices started to rise of the food. What is this? Okay, we only have 1 characteristic. I'm looping over that one characteristic. And now we are at line 222. I want to know this pointer, this thing here, could step into the set flat create info, or I could just print it. And then it tells me that that's the pointer. Buried inside a boost intrusive pointer. That looks like a stack pointer, something on the stack. That would be weird, isn't it? Wouldn't that be weird that it is on the stack? Fasik. And Aku says, I'm in open source game community, beyond all reason, that have some intention to move from OpenGL to Vulkan. Oh yeah, you should never have typed Vulkan in YouTube. Yes, my evil laugh. Maybe Vulkan is less difficult on my engine, I don't know. In the end, the objective is that it is easier, but easier to use. Not easier to write or look at the internals. And hello, unknown user is back as well. All the family is here. Did I already say hi to Hayretin? Oh, he left to study. He has his priorities right. Yeah. Okay. So I'm still very annoyed about this running while I just print something. Really? Who the hell wrote this debugger? Are you insane? Doesn't make any effing sense. But okay. I have to remember this pointer. Let's paste it in chat. You guys are my memory. So now we're going to call set flat create info. If I do a step, and then we enter operator square brackets. That's not interesting. And value allocator operator, still not interesting. And again operator. And back where we came from. And now we call operator arrow of the push intrusive pointer. And then finally get into set flat create info. So that's this same pointer, right? Yep, it is. Okay. Sometimes I just check something silly just to get a good feeling again. I mean, of course this is the same pointer, right? But it gives you a feeling of, you know, okay, you know, the base. This works at least. And then you can try a little bit further. So now we know the pointer, yeah, this pointer. And if I do next, I should at some point get here, yes. So the same pointer is being used to call run. And nothing can go wrong, right? I have no idea what it's doing. I'm gonna step into it to give a good feel about what this run is doing. We have to go through the same operators. Absolute idiot. Yep, now we are in run, I think. No, you're not. Still not there. Step. That improves intrusive pointer stuff. So next step. Now it is doing. If I would live 10,000 years or maybe 100,000 years, I would definitely write my own debugger. Because it's not been done in a sensible way. And there we went again. Scheduler, put it step, doesn't matter. We just crash. You see the thread that started running while I'm stepping through another thread, that one crashes. And now we don't have a chance to look what happens. Ridiculous. Not to mention that other thread, we were not inside Don't tell me we're inside thread pool 3. Well, we might have been. Is this the one that I was stepping through? Okay, well. Try it again. I mean, any sensible debugger would allow you to say here, step into run. Skipping everything except that call to run. But no, the only thing you can do is next, you skip everything or step and then you go into all kinds of functions that are called on this same line here. It's very annoying. I don't want to see this. Also here, these days, debug information is being stored on, I think, columns. I don't know which version, but it's there. So there is no reason not to have a way to step over this to that end, because this bloody closing brace is on the same line. There's no way to step over it. So if I do next, I skip my whole thing again, and then I do the step, I have to go into it again. I tell you, the authors of GDB are not using it, or they're just crazy idiots. Same thing, I cannot do next, I think. Yeah, if I do next now, because I don't want to, no, I can do step, this one doesn't do anything. Here I can do next because there's no closing brace. And then step. Now I'm here again, so I have to do step again. I'm here, now step. Nope, still not. Next, next, step. 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 Still intrusive pointer here. Nobody knows what this is. It looks like a constructor. Is it scary to do next? It's probably not even working because apparently we're not in the scope yet. Now I can do next, and then I have to do step, and then I do step again. And no, nobody knows where we are now. Constructor of the lambda or so. Something like that. Try step. No, let me try next here. Oops, scary. Let's do step. This is calling mcreate, so I should be able to do next now, yeah? And then step. And this can be a next, and a next, and a step. I mean, how is this user friendly? You have to continuously switch between next and step, and then still you're putting minutes into something that you don't want to do. Finally we get into the run. I could have set a breakpoint here, of course, but still. Calling run uses the immediate handler. Maybe that is not a smart thing to do. Immediate means that it starts running in the thread that calls run. Well, that's what it did before. But then what happens when you interrupt it? I don't know. Let's see what happens here. Again, all kinds of things that are... What the hell? Where are we? What is this doing here? We are creating a handle. No idea why. Oh, that's the handle of the AI thread for task handle. Okay. This is definitely a good reason why I don't like debuggers. I just like debug output. Often a lot easier to understand. Okay, we are entering here AI stateful task run. No flushing, so nobody knows what the default handler is. The default handler is immediate handler. Okay. There's the lambda function, stored and called back. Now we call reset. There must also be an easier way to detect, or easier way, already have a way to detect that we are running in GDB. And if we are, I think I should just flush everything. Because you don't see this debug output, because it's not being flushed. But, well, if you are stepping in the debugger, then you do want to flush it, right? Try to fix that, I guess. Now we are inside multiplex. False. Explain. No, okay, we're not inside multiplex implementation. We're just calling run. Initial run. Oops. No, I did an X instead of a step. Because it doesn't really matter. Sorry for debugging AI stateful task. Should not be needed even. But it's, I'm not pretending that this is understandable for anyone, of course. Not even for me, really. What I'm mostly interested in if this thread schedules itself or starts running the task. That's what I'm really looking for. And runs reset state first. Which one do we look at? Handler or current handler? Current handler. Current handler is immediate, and handler is also immediate. Yeah. Meh. Keep looping, probably true. That's not helpful. Then C-line would take up a lot of my screen, and I would be doing the exact same thing, but just on a smaller service, and I wouldn't have a new Vim as added. Last time I checked anyway. I guess it doesn't have any other handler than the immediate handler. It's definitely going to run in the immediate handler. Next. Yeah, they just started. It just runs initialize. Here we are inside our new task, characteristic range task. It's running this state and therefore calling initialize just as we want, but not in a different thread. Just in the same thread that's called run. And I'm totally okay with that, as long as it can be interrupted. But since we don't do that yet, it should not have a problem. And it is having a problem. So why? If now print the backtrace, then you see that we are inside characteristics range multiplex from AI stateful task multiplex, which eventually came because we were calling run. So run is calling our characteristic range task. And this run was being called from pipeline factory multiplex. So that is the pipeline factory itself is also a task. So when it is running, multiplex implementation is being called. So the thread that was running the pipeline factory is now running the characteristic range. I have a hypothesis what goes wrong. I thought it was easy to verify it like this, but it takes forever. So maybe we should have a different approach. My hypothesis is that actually that hypothesis doesn't hold. Yeah, it does. My hypothesis was that a different thread is running the same object at the same time that it is already being run. So while this is running, another thread is calling run on it. Well, that means that some other thread would call multiplex implementation with the same this pointer, while this thread is already inside of it. So maybe you should just let it crash and then check the threads, see if there are more than one thread inside this multiplex or inside yeah, because this thread is calling it, right? So you might be able to see that. I don't know, let's just run it again. Oh wait, let's delete all the breakpoints first, run it again. So now someone crashed, thread pool 0 asserted, I mean. The star is here. This is the one that stopped. It's thread pool 0. That's the thread that we are in. I can print a backtrace of that. And then you see that the pipeline factory was calling run, was calling AI stateful task multiplex on this pointer. That is then probably a characteristic range. So this characteristic range was running. Paste the pointer in the chat, and then it crashed for some reason. And my hypothesis is that some other thread is already running this same task. So let's see. Oh, where does this come from? Multiplex, you said multiplex. Invoke. Oh no, it's just a worker thread. Thought it was called from inside another task. Call back. Yeah, it's silly. Right, so now we find another thread, I guess. One of these threads. No, no other threads. Info threads. Uniform buffers. No idea what this is doing. Probably not running a task. Thread 1. Backtrace. Waiting. It's waiting. The condition variable. Okay. Then we have thread pool 1. That is thread 3. Yeah, I never call YY parse. Oh, this is a GL something. Okay, let's do a backtrace anyway. No? This is running the window task, which is busy with IMG. And it's compiling a shader. It is not related. Okay, let's do thread 4. Thread 4 is running a pipeline factory. And well, I didn't paste at this point of the pipeline factory. Can we still find that back? I need thread 3. I started again. This is just the beginning. The crash was here. Yeah, this is the backtrace of the first one. So the pipeline factory has this pointer of all that. And here we see one that has a different this pointer. Okay, so this is a different pipeline factory, and that calls run insert, calls multiplex implementation on characteristic range with this pointer, which is also different from the previous one. So that kills my hypothesis, unless another thread is doing it. We have more threads, right? This was thread 4. Let's try thread 5. Inside is syscall. This thread's not running. It's just in a thread pool, I guess. Something like that. Also doesn't look like running, or it's my IO thread. Epol wait. Yeah, it's the IO thread. I do the info thread. That was thread 6. It's event loop thread. Analysis of VKRT. And then thread 7 is our last hope. It's also not running. That's strange. Apparently a thread was started by NVIDIA driver. Yeah, I think my theory went out of the window. Then let's go back to the debug output method. Let's see who wins. The debugger totally failed, right? There's absolutely no way to find out what that was happening there. Now my debug output method. Output 2 is asserting and it is running pipeline factory initialized. It does not make any sense. Initialize X is a member function of the characteristic range, pipeline characteristic, which now should be running in its own task. Therefore, stateful task should have printed that it is running our new task. I don't know, how did I call it? Characteristic range underscore initialize or something like that. Note that every time we enter a new stateful task state, that prints it like this, running state whatever, and then we have an extra vertical bar here that keeps running until we leave this state. So you can follow the green bar, and then you know that you're all the time in the same function, running in the same state even. And this thing is doing a lot. There's other threads. So here is still inside the same state here. Never left. Inside that state we crash. Yeah, is that possible, man? It was calling initialize, not that it matters, but it was calling it's a bit too early. Initialize x0. Which is being called when initialize is being called of the uniform buffers test pipeline characteristic base, which was added by that type. So we add a characteristic here. And another one is added to a different factory. And this generate is starting the factory, the pipeline factory. Not starting it, sorry. It's giving it a signal that it can continue running. So the task got till here, set state to pipeline factory initialize and then waits for that signal. And then it continues running here. It's kind of strange way to use a task, I have to say. But this function, create pipeline factory, creates it in a normal way, calling stateful task create. And then it also calls run on it. That is, it calls run pipeline factory passing an index. My god, what's happening here? The index is the current size of pipeline factories. Then we push back the factory. So now it is at the index and pipeline factories index, and that's what you pass. Okay. So this is the factory that we just created. You could not pass factory because we moved it. So inside this factor, I guess. the vector? A vector stores in boost intrusive pointers. Okay, so we're calling run pipeline factory with a boost intrusive pointer to a not yet running task factory, and then we call run on it, running it in medium priority queue. So yes, this is not only creating it but also running it. And then by the time we call generate, we call a signal on it. We signal it so that it continues running. But yeah, what I do not understand is that we do not see a printing of. Oh wait, now I understand it. I have debug output suppressed for the others. Damn. Okay. Yeah, we need to pass true for debugging to the constructor of the characteristic thing. Let's find that. Yeah, here it's created, and now we pass owning window, and optionally more constructor arguments, which should just simply be passed to add characteristic, aka here, and that's the same thing as here. I just want to debug it. So this turns on stateful task debug output. Or not. In instantiation of void vulkan pipeline factory handle add characteristic const tasking grown is window pointer asks is bool. We cannot pass a bool to characteristic 0. Quite from here, no matching function for call to Yep, okay. Well, what? You gotta be kidding me. Thank God I can hear myself also, although I'm not listening back through YouTube, but I'm listening to what I send to OBS. Yeah, well, whatever. I just have to edit a lot of clauses and add that boolean, I guess. But I'm using the base clause here. That should work. It uses the base clause again, which does not have support. And characteristic range does already have support, but only after index type begin and end. So you have to pass a 0 and a 1 then. Might as well. Nah, not there. Here, there, here, there. I don't know. Okay, let's do it like this. 0, 1. Why? Yeah, I wonder, Fritz. Why is it relaxing? What exactly are you doing then? Are you just sitting in a comfy chair and watching it, listening to me, or are you doing something else in the meantime? Like Bear, working on your own program or something, I mean. In which case only my voice would be relaxing. It's still not compiling. Why? So you listen to me, or I mean, how can it be relaxing if you're playing a game and not watching it? It's pure the audio then. Required from here. Error. No matching function for. Yeah, what? Something like missing. Expected 2 arguments, provided 1. Now the debug thing is missing here. We have to add it everywhere, of course. Edit this one. Add characteristic. Yeah. That sounds pretty skillful. I would not be able to do that. I just follow the vertical bar again. This vertical bar should be the state that we are in. And I can use my mouse to scroll in less as well. Less R gives me the colors. Better than the editor. Yeah, well, still right. No, here it is. What is happening here? Well, I guess the adventure starts here. It was just starting because I was thinking about what the hell is this indentation. I would have understood a double indentation, but the bar would have been here and then one more task. You would expect it here. But it's not here, and it's not here. It's here. Okay, whatever. So we have running here, running state, pipeline factory initialized, and then all the other stateful task was suppressed. But in fact, that calls run with the immediate default handler, and a lambda is called back, which then calls a reset on that. You can highlight this one. This is our task. This is the I don't see it, but it should be the characteristic range task. It should be printing it. Or maybe only one by the time it prints running state. And right now we're just running reset, initialize. Now it's here. There it is. It's blind. So yeah, it's running characteristic range initialize. That's what we want right here. Initialize, and then it. Because it's running that, it calls initialize X, which is going to do a lot of things totally correctly, and ends with a crash. Or an assert rather. Yeah, it's just doing a lot of things here, lots. And then it says you did not call wait. Oh. No. Kill me. Why am I so stupid? I think I'm gonna stop coding very soon. It's not funny anymore. It's not funny anymore. Yeah, no, the assert spelled it out. It spelled it out, literally. And I didn't see it. Yeah, if this fails, then the run state didn't change and neither wait or yield was called. What was the last task that we added? The characteristic task. And what did I do? I looked at the pipeline factory. And only at the pipeline factory. How stupid can you be? This is about the characteristic task. The one that I just added. And indeed, that is exactly not doing that. Complete idiot. Okay, let's find that task. Where was it? Characteristic task. I don't know where it is. Characteristic range. It's like right here. Yeah, come on, shotgun. Tell us when it is a prime number. And I'm just kidding, of course, because 23 is a prime number, right? So, what we shall do here is do not call wait or anything. I'm calling initialize and then I break. Well, really, we should just finish. I can do set state characteristic done and then break. Fix it. So it's telling us you did not call yield, you did not call wait, and you did not call set state. The result would be, normally, as soon as I break out of it, this stateful task engine, I would say, oh, you're still running, and immediately return here with the same run state, calling initialize again. That would be a tight loop. It would be infinitely long calling initialize, so that's not good. That's why it asserted. But you must finish because only when we finish you do this lambda callback, which calls a signal on the parent, which causes it to continue running. Oh, I wanted to run that. It's still quarters. No, why? Oh, that's funny. Still the same thing? No, don't tell me it's the same thing. Copy. Now what? Can only be run when in one of these states. Oh, so run is being called again on the same thing. This time. No. Yep, so we crash here. Can only be run when in one of these states. So we're being called. Run is being called. Okay, let's do a backtrace so we can see that. Run is being called. And that's not allowed because the base state is something else. What is the base state? No state R in the context. Really? I have to do up. Killed. State is killed. We call run while we are being killed. Yep, I forgot how to use AI stateful task. It's official. This is a niche case, of course, running a task twice. Not really used to doing that. Maybe I have documentation about it. It's about writing a task. How far did we get? Changing state. Yielding, waiting. Doesn't go further than waiting. Task life cycle, maybe. Creation, initiation, running, and destruction. Okay, the callback function does not call run. No, it doesn't. It just called signal on the parent and then it forgot about itself. Then the task is deleted upon the return from the callback. Aha. The whole bloody task doesn't exist anymore. But that doesn't explain that if I do keep a boost intrusive pointer around, and I do, then what I have to do so I can run it again. Maybe I have to call reset inside run. Or something like that. Stupid. Yeah, restart the finished task is just finished. It should be possible. But then it says you can only call it from finish implementation or the callback function. So that's pretty literally restarted. I don't want to do that, I just want to abuse / reuse an object, even with a different entry point. I really just want to reset the whole thing, so it doesn't even know that I did wrong before. Okay, see you, Fritz. I'm having a fight with my own library. It doesn't want me to call run on something that just finished. Again, calling it again. And the reason is that the state is killed. I suppose that makes sense, otherwise my smarter self from the past would not have written it like that. But, what if I just want it? See, running task, I want to go to here. Let's look in the guts of stateful task and then find out what we need to do to reset it. I'm not supposed to read me as a... No. Another read me. You never know. Yeah, this is the whole point, I think, right? So the state is killed, and now we want to go back to reset. That's what I want. That shouldn't be too hard. I'm pretty sure that the involves BS reset, assigning, that's signing off. So that happens when we construct it, or what is this? That's a multiplex state. Can only destruct it when in the state killed or in reset state. Idle state before run is called. Reference count is 0 except for a possible external boost intrusive pointer. Yeah, reset is being set here. What is this about detecting a late abort? Don't want to go on that route. It's not really official. Here's another one. Call back. Ah, run was called, not followed by kill. That seems to be the right way. But yeah, if I call run from the callback, then I think it's going to run immediately. Seems to be no normal way. This seems to be the best bet. So okay, what happens if I call run from the callback? What happens exactly then? That's a nice ASCII art. Yeah. It should be a way to get from killed to reset, I think. If you still have the some boost intrusive pointer pointing to it. Why not? I don't understand this error. We call run, and then it says that it goes to idle until run is called. Fix me. We'll never know, I guess. think the conclusion has to be that I'm trying to do something with my tasks that is not designed for. A scene asks, hello, where do killed come from? Call back or from the finished? I don't understand the question. Killed is his internal state of the task, and it is set to killed at the moment that you return from callback without having called a run, or when you explicitly call kill. That's repeating what we just read, so I don't understand the question, I guess. Yeah, we could call this function reset, although I doubt I can do that. Can at most call run, but well, I think I should give up. It's just not, my tasks are not intended to be used as a two task in one. Okay, let me think what I want to do then. Let's try the following. We'll run initialize, and then after initialize is finished, we just go to the fill state. And well, not really. I want it to wait. Also, it's not calling the call back now, so I have to somehow call a call back from here. The characteristic range has a pointer, I think, to the owning factory, right? Yeah. So we call initialize, and then after that's finished, we tell the owning factory that that's finished. The characteristic is initialized. I even call it range because it says so. And the task itself is not finished. This then goes to fill. Let's say fill, but we want to wait on the signal first. So I'm going to break here. We're going to wait for that we must run fill. Do fill, whatever. But there is a possibility that you just want to kill it. So we have initialize was already run. You do not want to call fill anymore. But then I guess we can just call abort on it. So this is more or less an infinite loop. I don't have it done anymore. It is always exited by fill. So here we wait again for the next signal. And of course it has to tell the owning factory that it finished. Okay, so this task now runs initialize and then tells the owning factory that it's done. Then it waits for a signal, do fill. And then it continues with fill, call fill, tell the owning factory that fill was called, and then waits again for a new signal, and then it just continues and keeps running this until someone calls abort on it. And I'm not sure if we're waiting. If you call abort while it is waiting, I guess it's aborting anyway, right? Abort should wake it up, even if it is waiting. Let's see. Is waiting is false. Okay, is waiting. So when it is idle, and we do our stuff. If is waiting and not self-locked, insert abort. So this kind of wakes it up, I guess. Should work. Right, I think this works. Then we have to add this function, of course. And I have to add, let's first add these things. Do fill and yeah, the do fill signal must be added to characteristic range. And okay, No examples here. Right, that's our do fill signal. It's just an UN32. So you can have 32 signals. I think they should be public. I want to send a signal from the outside. Okay. Then the characteristic to the factory, pipeline factory. And I forgot how I called it. So let's add that one as well. This function must be added. Must be public, eh? It's being called from external stuff. Yeah, where can we add that? I don't know. Just add it somewhere. These are called from characteristic range. So they replaced the callback. Let's see how we can do that. Yeah, let's say so I do not have a callback anymore. I don't think so. No. Yeah, we don't have a success either anymore, I think. Or we do. We do now. So this is basically our pseudo callback now, which you just call without exiting or stopping the task. Without it, the task is really finished. And then I guess it does exactly the same thing. And the parent is just us. Since the parent is waiting, there's also no danger that a parent is deleted. The parent is not deleted because it's still running. And it's still running because it doesn't continue running until all the child tasks are finished. And it gets its signal. So that's automatically safe. Okay, so I have a bool success here now. Okay, so it looks okay. Yeah. Oh. There is something wrong. Oh, yeah. This is not an atomic. Must be atomic as well, I suppose. And I don't think you can do an and becomes all atomic. I mean, either I have to make this a read modify write, or we must run the risk to have a cache miss. I think that makes a lot more sense. Okay, I'm using a branch. A branch. Right, now there is a theoretical race condition here. Well, there is not, because I'm using What's it called? Sequential something. What? Cannot remember that. Let's refresh my memory model. Sequential consistent, that's the word. I don't like to use a sequential consistence though. What is this short something? Well, I remember it anyway. So I'm not using a weak memory order here. Therefore, we're using a sequential consistent, which means that if this is being executed before this one, then it's going to be visible here. Say thread A sets it to false and thread B does not set it to false, but decrements this thing to 0, getting 1 back and gets 0. And what is my guarantee? That thread B will see that thread A has set it to 0. The guarantee is that the only way that thread B was seeing a 1 here is when thread A not only set it to 0, but also executed this line. So what we could do is make this relaxed and this one acquire release. Yeah, I'm normally I really hate to use sequential consistent because then all of these things use a lock assembly instruction. Each and every one of them, which is totally not necessary. So I think indeed what we really want is that this one would guarantee that the thread that all threads are decremented and wrote false to this one must have their memory flushed. So this must be setting it to false must be visible in all other threads. Now that is then going to be a read modify write operation, which has also special things. It might in fact always automatically be I forgot that also. Horrible memory. What was so special about a read modify write? Oh no, I don't know anymore. Oh, this is really bad. And this is not something you can quickly look up. It is like the memory model stuff is so difficult. I studied it for a full year. Now it turns out to be a wasted year if I forget things. Okay, I don't know, man. Melly me, only if it motivates you. If it makes you enthusiastic for, wow, this is cool stuff. Yeah, it's not like you can type this into Google either. think I'm going to ignore the read modify write part of it, and I'm still going to using weak memory access stuff, because that's what I do everywhere and I don't want to stop with that. So this becomes a store false. I'm gonna use standard memory order, I think it is. Relaxed. And this can be a load. Memory order relaxed. Still must be an atomic, because otherwise it's possible that one thread... No, actually it's not. Yeah, theoretically it's possible that two threads fail and that they are both storing data to this variable at the same time, which is not allowed unless it is an atomic. So it must be an atomic. And then here we need acquire release. So this becomes fetch sub. Let's fetch it 1 as 1. Fetch sub 1. Memory order acquire release. Not working. Or do we have two of them? Acquire. The default is sequential consistent, and we have also acquire release. Yeah. I don't know what I copied. The whole thing. At any rate, I avoided this way. I avoided sequential consistent, and I just don't want that. I don't like that at all. Yassine says task success is false. Yeah, that's sequential consistent, so I replace it with this. These are the kind of, if this is wrong, then these are the kind of bugs you will never find. Never, ever, ever. So if it is important, and it isn't in this case, then you really must be 100% sure. And the only way to be 100% sure is by running this code in a simulator. So you have the weak memory model simulators, and then they will, that's the only way to be sure. Absolutely the only way. But yeah, I have done that in the past for really important pieces of code. But in this case, I just don't want to spend 2 hours checking this, because it's on Intel. It's not, doesn't even matter what you do. So only if this would ever be ported to ARM, it would become, and even then, I mean, it's just never ever going to be imported, really. So I'm not going to check it, but I'm pretty sure it's correct, despite my failing memory. Anyway, so I moved the call back now to this function here. Yeah, I need to pass that success thing. Don't have that anymore, or do we? Yeah, we do. So this is of course always true. Let's do that here as well. And then not success means that we failed, that we aborted. Abort implementation. So if we are aborted, then we will probably not call these things. So we have to call, which one? That depends again on, I guess, if, oh no, we cannot know that. We cannot know that. As if we are ever going to be aborted. All right, we are going to be aborted. While waiting. We are going to be aborted. Oh, so that. Yeah, not possible. The race conditions are flying around your ears. Multi-threading is not easy. And then I wrote stateful task, actually especially to make threading easier. But then the only way to do this is by providing a callback. Must provide a callback. Let me think. Well, let's make it easy. We're not going to return success here. It's just always success in the first place. And then not success is just simply that abort is being called on it. And we can do that. By using the right run. This one, I think, on a board, right? Is that the only one here on a board? Yeah, you can just call run and then pass the parent and a condition. Then when it finishes, it will signal the parent with that condition. And if the child task is aborted, then it will abort the parent by default. Which is what you want. Well, that's the parent, and then the condition is that it's finished, but it's never going to finish because it just doesn't finish. Instead, this thing is going to go into the state of running, waiting for the fill signal or something like that. I guess I do need a pseudo signal, because in the end we are going to abort it ourselves, and then we get that signal back, which I then want to ignore. So I think I can abuse this one. It's going to ignore this one, I think. Let's see. My music stopped again. It's got stuck. Not again. I mean, we passed this point by the time we abort, somewhere below, and we're not waiting for it anymore. And signals that we're not waiting for are just ignored. So you can just use that one here. Because they never finish anyway. They still don't work. They still can't work, I mean. It can't work because now we are running in the immediate handler. So the thread that calls run is going to execute it. And then what happens when it waits? It's a good question. It should return. It should add it to something, but what is it going to add to? It doesn't know in stateful task engine, or doesn't know the thread pool, doesn't know anything, right? I'm not sure, but I think it is not working. But I also hope that it will tell us. It should assert and then tell me what is wrong. I'm gonna keep it like this. And I see that it is 1.5 hours past the point that I should have stopped. Although I started very late. But I think I have to stop the stream now. That's the fill one. Yeah. I think I should wait with the allow deletion until the signal is sent. That makes more sense. And I do it, you know, in the same function. Although we're calling, yeah, I'm calling inhibit deletion now for once for each child task. And then I have the child task call allow deletion. But they have their own counter. And then when all of them finished, they call a signal. So why not just inhibit deletion here. And then allow deletion once. What do we get here? Actually, you don't need that either. It's again the same thing. While it's waiting, it has its own increment. The whole thing is not necessary. There's an eye here that we don't have anymore. Okay, I just wanted to see if it compiles. It compiles. So if I run it, what happens? Some kind of interesting assert. Can only be run one in one of these states still. Yeah, I'm running it again. Okay, I'm just gonna stop and we'll continue tomorrow.